Actually, my presentation is more about, okay, it's half about the experience of European countries and European development in this area, because in Ukraine here we only started to look at energy crops and just to understand and think what we can do with them, what we need, what kind of support we need to use them. And actually the issue of energy crops is and the issue appeared when those who built boiler houses or thermal power plants just start thinking about the secure supply of biomass for their plants. So sometimes, as it was said before, you have some agreements with farmers, but sometimes these agreements can broke, so you need safe supplies of biomass, and so you need to think about your own cultivation of crops that can be used for combustion or for, I guess, production. Actually, we try to look at the experience of the European Union and analyzed some reports of the European Biomass Association, which estimates the current potential of energy crops as 44-47 million tons of oil equivalent a year. And as you know, one of the EU targets for 2020 is to reach 138 million tons of oil equivalent of biomass in the gross annual energy consumption. And so the available potential of energy crops allows covering about 1/3 of this target. We can say that the total area under lignous cellulosic energy crops in the European countries is also another report of European Energy Association. It's about 130-140,000 hectares in different European countries, and it's for solid biofuels and for energy crops under intended for liquid biofuels. Actually, the areas are much bigger. You know, maybe these figures. It exceeds 2.5 million hectares in the EU, and as for the lignocellulosic energy crops, I want to point that their main areas are. The main areas are in Romania. Almost half of all lignocellulosic energy crops are there under switchgrass, 50,000 hectares, and also big areas in Finland under reed canary grass, and in United Kingdom and in East Kansas. And so, what can we say about these areas is we had also a conference 2 days ago, and there was a representative from Lithuania, and these are the figures for 2011, and he also pointed about the areas for energy crops cultivation is now for 2013 is already 11,000 hectares. So it's proceeding. As for energy crops for liquid biofuels, almost half of them are located in Germany, and it's about, you can see, 746 and 46,000 hectares. And as for crops for solid biofuels, it's about 11,000 hectares. Okay, we look at the EU to understand what kind of support is there, and to maybe to take the experience and to try to use it here in Ukraine. So the main support mechanisms are the feed-in tariff for electricity produced from biomass, and also the support subsidy for the establishment of for cultivation of energy crops. So it's like a subsidy for 1 hectare, about 500 euros, for example, for hectare in Sweden, you can see, and also in other countries the similar supporting mechanisms. Energy crops can, well, the yields of energy crops differ very much depending on their temperature conditions and water requirements. They have different frost resistance and drought resistance, and this can be the first like orienteer to understand where to grow them, in what areas. And so it's for future, actually, in Ukraine here we are thinking about such a map with areas, and to show the map of Ukraine where and what crops can be planted in what areas. Okay, but when you are thinking about bioenergy, about energy crops, here we see two words, energy and crops. So two sciences are here, so planting and harvesting, and also bioenergy, so it's combustion or production of liquid biofuels. So here you have to look at fuel characteristics of energy crops. And we can say that here is in this table a comparison of 3 energy crops, miscanthus, milo, and poplar, and with the straw of grain crops and with wood chips. And we can say that fuel characteristics of willow and poplar are almost very close to the wood chips, and only for miscanthus we can note their ash content is higher, but still ash content is lower than that of straw. So it's this crop is interesting from that point of view than the straw. And also here we see in this table just comparison of different herbaceous energy crops, and also this data was taken from European analysis, from European reports, and I want to point out that this information is also presented with all links and with all data in the position paper of Ukrainian Bioenergy Association, and you can see from where we took this information, and okay, what we know from here, it's okay, actually the content of nitrogen, and we can see that it's rather high, but we can explain it with use of fertilizers, and that's the explanation for that. And actually we can, when we talk about energy crops, we should note that we can't say it's that this fuel is like wood pellets. So it differs. It has its own peculiarities, and producers of equipment should take them into account. So one of them is the such a parameter, which is chlor to sulfur. Yeah. So this parameter should not exceed 1. The ratio chlor to sulfur shouldn't exceed, because there will appear corrosion of the equipment. So it should. There are some ideas how to decrease this parameter, but it's just technical things. Okay, and as for the emissions, yes, it's a very important issue about the emissions, but we can see from here that emissions of energy crops actually are higher than that from wood combustion. But, for example, if compare them to Austrian limiting values for wood-fired plants, they are within the limits. So, if their limiting values are not unreasonably high, so it is within the limits for emissions. For switchgrass, you can see giant reed, miscanthus is within the limits. Okay, we see here the comparison, and I want to point out about the miscanthus. So this energy crop is within the limits, and it's very interesting from this point of view. What about Ukraine? Here we have a number of companies that is now planting energy crops, but talking with them, they mentioned some problems that they faced, and so Bioenergy Association is want to make them publicly known in order to overcome. Okay, so what are the problems with grown energy crops? Okay, energy crops are not included in the classifier of agricultural crops, and only willow is included as a technical crop, and other crops are absent. What is the problem with it? You can't you can't grow these crops in agricultural land. You're not allowed. You're not allowed to grow them. So only if they are in the classifier. Actually, there is a need to, and also the Institute of Energy Crops and Sugar Beet just point out the idea that there should be a classifier of energy crops, not of agricultural crops, but energy crops, and all the energy crops should be included in this classifier, because if you, willow is in this in the agricultural crops classified, but actually willow for a big okay, we can't say that it's a technical crop, it's an energy crop. So we need a classifier for energy crops. Okay, the next one, there is problem. Sometimes the producers are demanded to pay VAT and concluding contracts with investors, though they haven't produced anything yet. So if they want some investment in their projects, they say, okay, what will be your part? The investor asks him. He said, okay, I have the energy crops. I have a lot of material, and if they want to contract their relations, then the authority can say, okay, you have this product, pay VAT for it, but it's not a problem. It's the material for growing that they personally growed, and they didn't buy. They do not sell it, but they should pay this. It's also a problem. And also, produce of energy crops now isn't considered as an agricultural producer. What does it mean? It means that he doesn't have respective benefits. For example, agricultural producers have some equipment lease. So producers of energy crops do not have such benefits. So what are the incentives? The incentives that we see are the next. Okay, we think that the government should give a subsidy for energy crop plantations in the amount of 620 euros per hectare, and should also support with partial paying of commercial interest on a credit. What about land? Some slide. Okay. According to State Statistic Service of Ukraine, here we have about 27.8. Okay, the total arable area is 32.5 million hectares. From this area, sown area is 27.8. Fallow, that is waiting for use, is 1.2, and unused agricultural land is 3.5 million hectares. These calculations are for 2012. Each year, this amount of area, this area can little differ. It will depend on the sown area that can become, but it's always within 3-5 million hectares. So these lands can potentially be used for growing energy crops. And the conception of Bioenergy Association of Ukraine for growing energy crops is the following. We just, for future, we can say that these energy crops like willow, miscanthus and poplar that are most productive nowadays and well known and also busted. So we proposed such division and such areas under them. So now we have about 3,000 hectares of energy crops, and it's almost willow. For willow it's almost 2,000 hectares, and for future we propose 2012 to increase this area to 200,000 hectares and to reach 1 million hectares in 2013. Okay, not only lignocellulosic energy crops are included in this conception, but also maize for production of biogas. So it's, I forgot to mention, it's 1 million hectares for it. Below you can see the structure of the harvest, and also the total harvest of energy crops can reach about 5 million tons of coal equivalent a year in 2030. So we can reach this target actually. So 1 million if we have 3-4 million hectares of unused land. So it's very realistic. And it's some diagrams about return of investment. So for the poplar plantation in Ukraine with 2-year rotation cycle, it's just these graphics are shown to illustrate what should be the subsidy from the government to support this process, the plantations of energy crops. And so in the first diagram you can see the red line is with subsidy. It's shown in greenness, 10,000 greenness. Some time ago it was equal to 620 euros. Okay, and blue line is with no subsidy, and we can say that if there will be no subsidy, then the return of investment will be about 6 years, a little less than 6 years. But if subsidy from government will be received, then this return on investment will be up to 4 years. So actually, when the sale price will be 400 hryvnias per ton of energy crops. And to understand how we can vary the price with the